three forms of our quadratic equations, what does the standard form tell you? What does it give you right away? Gives you the y-intercept, okay? And so, guys, your y-intercept is this lovely little guy here. The standard form gives you that y-intercept, which is really, really nice, okay? The standard form also, you have your a value. And guys, the a value tells you a couple different things. It tells you if it opens up or down, right? If your a value is positive, it opens up. If your a value is negative, it opens down. If your a value is greater than 1, if it's a number that's bigger than 1 or bigger than negative 1, then it is a narrow little function there, right? If it's wider than 1, or if it's smaller than 1, it's a wider function. It's that vertical compression, okay? So the standard form is nice because it gives you your y-intercept and it gives you your lovely little a value. Your vertex form still gives you the exact same a value, all right? So your a value is exactly the same. But what does the vertex form give us, y'all? Hopefully it's pretty self-explanatory. Yes, it gives you the vertex, okay? And your vertex is that lovely HK, right? So your vertex gives you the vertex, right? So if you are given the vertex, I highly recommend doing it in vertex form. Also, vertex form is really great for transformations, right? It tells you if it shifts to the left, to the right. The H tells you if it shifts left or left or right. The K tells you if it shifts up or down. Okay? What does the intercept form give you? The x-intercepts, all right? It gives you the x-intercepts, or the roots, right? That's what those R's stand for. Gives you your x-intercepts, okay? And it's R1, 0, and R2, 0, right? So it gives you your two different x-intercepts, or you can also call them roots. What is the other lovely term we have for that as well? Zeros, okay? So now I kind of wrote this out of order. I like to think of it R-O-X, so roots, zeros, and x-intercepts, because math rocks, right? So the roots, the zeros, and the x-intercepts. All right, guys, so these are the three forms. One thing I want you guys to notice is the A is the exact same in all of them. It controls whether it opens up or down. It controls how wide or how skinny it is, okay? The roots are those lovely x-intercepts. That's why they're called R1 and R2. It's that roots, all right? And so that's what you get from your intercept form. All right, so guys, now what we are going to do is we are going to talk about how to find our vertex or our axis of symmetry from just an equation. And there's a few different things that we can do, all right? So what I'm going to do is I'm going to give you guys a little page here, okay? So if I want you to find the vertex or the axis of symmetry of these equations, if we wanted to do this without any technology, what would we do to find that axis of symmetry? What equation would we use? Do y'all remember? Yeah, so your x is equal to negative b over 2a. So y'all, if we didn't have any calculators or anything like that, you could do this by hand as long as it's in standard form, right? If it was in vertex form, you could just have your vertex. But guys, what I want y'all to do is I want us to I want us to practice doing this with our calculator, all right? So this is what we would do if we had no calculator, but I want us to practice with the calculator, okay? So I want everyone to take their lovely calculator, all right? And I'm going ahead, I just reset my memory. I know y'all already did that, okay? So we have this lovely little calculator. It takes a second to reset. Ugh. All right, there we go. So my memory's cleared. And I'm going to go to y equals, and I'm going to type in x squared minus 2x plus 9. Do y'all feel good about that? when I hit graph here? Awesome. When I hit graph, ooh, I see that my parabola is like way up here in the little corner. Yes, sir. 212.
212?
It's where my room is, but over on that side. Okay. You're good. Okay. So guys, do y'all see the little parabola? It's way up there in the little corner. So we typed in x squared minus 2x plus 9. We type in graph. So guys, generally speaking, where is my vertex probably going to be? You can use your little arrows here. And I'm going to kind of scroll up to the top here. And look at that. Okay, there we go. So it's going to be around 0.98, so around 1.8. But guys, how can we really be sure where the vertex is? What can we do? Let's look at the table. Exactly. So guys, I'm going to go look in the table, and I'm going to say, remember I guessed it was about 1.8. So I'm going to put that 1.8 kind of in the center of my table here. Okay? And the reason why I do that is I'm going to zoom in a smidge. Oh gosh, that's super annoying. Okay, so when I do that, what you can see is around that vertex point, all of my y values are mirrored. You can see around the 1.8, the y values are mirrored. 9, 9, 12, 12, 17, 17, 24, 24, 33, 33. So y'all can see that all those y values are mirrored around my vertex. Do y'all see that? So we would go back here and I would say, okay, so my vertex is 1.8, all right? So then I would go ahead and list out my vertex as 1.8. And what would my axis of symmetry be, y'all? What would the axis of symmetry be? If my vertex is 1.8, the axis of symmetry is x equals 1. Guys, your axis of symmetry is always an equation. Your vertex is always a point. Okay? So the vertex is an equation. Is a point. The axis of symmetry is an equation. Do y'all feel good about that? Do you guys feel good about finding the vertex just from the equation on the calculator? Okay? So, and also guys, was this a minimum or a maximum? It was a minimum because it was opening up. So guys, in this case, my minimum value was 8. So the lowest value I had was 8. So what I want you guys to do is I want you guys to identify the vertex, the axis of symmetry, and the minimum on these next two using your technology. All right, guys? So using your technology, I want you to find those guys there. Hopefully, so y'all, these are the answers for numbers 2 and 3. So y'all, our vertex for number 2 was -5, 2. So that meant our axis of symmetry was x equals -5. So the axis of symmetry is an equation. We had a minimum of 2 because our graph opened up. Okay? Now, y'all, what I want you to do is, guys, I want to see what happens, how we can find the vertex or the minimum or the maximum if it's not a nice, easy whole number. Do you guys see how all these numbers were nice and pretty and whole? Okay, guys, that's not always the case. So this is where your calculator comes in super handy when things don't work perfectly. So I'm actually going to jump here. Okay, I have some other ones we're going to do in a minute. But guys, I want us to find the minimum or maximum value of these problems. They're not going to be nice, pretty, whole numbers. Okay? So guys, check this out. For number 7, if I type in, I want everyone to type this in for me. -9x squared minus 12.4x. The decimals kind of give it away. Oh, it's -0.9, isn't it? That would be interesting. -0.9x squared minus 12.4x minus 36.9. So when I hit graph, this is generally what it should look like. So guys, this is generally what it should look like. Do y'all feel good about that? We know, why do we know that it's going to open down? because my A value is negative. So guys, we know that this one is going to open down, so we know that we are trying to find the maximum, right? So we want to find the maximum in this case. All right, so we're going to go back here. And y'all, unfortunately, if I go to my table like I did on this last one, I can see that it's generally going to be at maybe -7. How do y'all feel about that? Okay, generally around -7 and 5, something. Let's see. So guys, if I go to my table, is my table perfectly mirrored, y'all? No. So unfortunately, this means that my vertex is not at a perfectly even whole number point. Does that make sense, y'all? My table around that -7, it looks like it's around here, right? That's where it starts to change direction. But y'all, it's not a perfect even number. So I'm going to show you how to find this in your calculator, okay? When you have a weird decimal. So what you guys do is we're going to go back. If you look at the top of your calculator, we have y equals, window, zoom, trace, graph. Guys, above the word trace, what do you see? Calc. That's like calculate. So what we are going to do is we are going to calculate something. So guys, remember, what are we looking for? The minimum or the maximum? The maximum. So I'm going to hit second trace. And guys, what I'm going to want to calculate is the maximum value. So if I'm looking for the vertex, I want the maximum value. So I go ahead in here, I hit second trace, then I scroll down and I hit maximum. And guys, the first question it asks is, what is your left bound of your maximum? So what you are going to need to do is you're going to need to take this little arrow and arrow over until you see it. It starts at 0, 0, by the way. So you want to see, there it is. You see the little cursor is blinking on my graph there? Okay? So I want to stick, the first time I do this, I want to stick it to the left of my maximum value because we are creating the left bound. Okay? So I'm going to hit enter and it's going to make a nice little line on there. And then I'm going to scroll and I want to do it to the right of my maximum value because I'm creating the right bound, the boundary, the left boundary, the right boundary. And the reason we have to do this, guys, is because this works for multiple times of equations. In quadratic functions, you only have a min or a max, but in some functions, you might have both a min and a max, like in a cubic function. So anyway, so then it says the last thing it says is guess. So I kind of scrolled it back to the center and I hit guess. When I hit enter, it tells me the actual maximum value to the decimal. -6.88889 and 5.81. So guys, my actual vertex would be -6.89 and 5.81. So that is my actual vertex for this graph. It is not a clean, pretty number. Do y'all see that? It's not a clean, pretty number. So what you have to do is you have to create the left bound, create the right bound, and then do a little guess. Okay? So I'm going to put the little steps here for you guys to find the min or maximum value, guys. You want to make sure that you do the second trace or second calc. Okay, that's our first step. You do second trace. And then you select the min or the max. And then you have to create the left bound and the right boundary. Create the left boundary, and the right boundary. And once you've done that, you guess, and you should be able to do that. So guys, you have to go in there and you have to create a left boundary, a right boundary, and then you go ahead and you select it there. All right, guys? So so what I want you guys to do is I want you guys to actually practice doing this, because these are weird decimal values for your minimum and your maximum, okay? These are weird decimal values. So I want you guys to actually practice using the calculator to do that, okay? Using those levels. Guys, one mistake that I saw a few students making is you have to make sure you're selecting the correct one, minimum or maximum, okay? So that's why I like to look at this and say, oh, my A is positive, so it's happy. I'm looking for my minimum, okay? A is negative, it's sad, so I'm looking for my maximum. Also, guys, if you noticed on number 4 or number 9 here, if you guys had typed this one in, negative 1.8x squared plus 14.4x minus 32, guys, what you would have noticed is actually, oh, there's our little graph. Guys, this is actually on your table correctly. Okay, I'm going to zoom in a smidge. So, guys, because the value is right there at 4, so y'all, you could have found this vertex on your table because your x value was a whole number. But sometimes when you see decimals like that, they look nasty, so you can go ahead and just do it with the second calculate or the second trace, and you guys can still find it that way. You would have gotten the same answer by checking on your table or by doing, let's see, oops, wrong thing. Second calculate, I keep doing the wrong thing. Sorry, y'all. There we go. So I'd want to look for the maximum. The biggest trick is finding that little cursor, right? You create a left boundary, you create a right boundary, and then you go back to your center. And we still get 4.001 and negative 3.2. So it's 4 and negative 3.2. Do y'all feel good about that? Excellent. Okay, so guys, that is how you can find your min or your maximum with technology, okay? Now, guys, the same is going to be true for your zeros of a function. All right, so I'm going to go back here. Okay, guys, well, first of all, what are the zeros of a function again? Do you guys remember? What are the zeros of my function? X-intercepts. So, guys, remember, R, O, X, roots. The R stands for roots. The 0, the O stands for zeros, and the X stands for X-intercepts. So, y'all, we want to find the X-intercepts of the function. Now, guys, what is one way that you can find the X-intercepts of a function? If you're just looking at the table, let's do it with number 5 here. All right, type in number 5. We're going to do y equals 2x squared plus 8x plus 6. Okay, this one's nice and pretty. Okay, we're going to look here. We're going to hit graph. I want to see, oh, where does it cross my x-intercepts? Well, y'all, we're not exactly sure, so let's go to the table. All right, guys, where does it cross your x-intercepts, y'all? Negative 3 and negative 1. So, y'all, my zeros are negative 3 and negative 1. So, y'all, you want to find, so if you look at your table, you want to find when y is equal to 0. So that worked really well for number 5 here, right? If we can look at our table and find where y is equal to 0. So that was what? Negative 3, 0, and negative 1, 0. Okay? But guys, once again, that works really great when you have nice, pretty whole numbers. Are you always going to have nice, pretty whole numbers? No, unfortunately. So let's see what we can do with this number 4 here, okay? Let's try this guy. Negative 1.7x squared, oops, minus 11x minus 13.2. So guys, when I hit graph, ladies and gentlemen, so when I hit graph, does it look like we're going to have clean x-intercepts, y'all? Are they going to be weird decimals? I think they're going to be weird decimals. And guys, check it out. You can even go to your table and see, oh, does my y ever equal 0? No, it kind of skips right over it. It goes from negative to positive, and it goes from positive to negative. So it skips right over it. So guys, there are some times where your y does not equal 0 on your table. But we know it has intercepts because we can literally physically see them on the graph, right? So what you can do, guys, is this is where you can go back to that second trace. And this time, what do you think we're going to be looking for? Do you think we're going to be looking for the min or the max? You're going to be looking for the zeros. But guys, there are 2 zeros to be found, so you have to do it twice. So I'm going to create a left boundary and a right boundary around this 0 and hit enter. So my first 0 was negative 4.88. So I'm going to put that here. So we have negative 4.880. And then my second 0, I have to do it again. Second calc, find my 0. So I'm going to do a left boundary and a right boundary. Kind of go to the left side and the right side. Then you hit your guess in the center, and it's negative 1.59. So my negative 1.59. So my two x-intercepts were negative 4.88 and negative 1.59. Do y'all feel good about that? So guys, you can actually find your x-intercepts here using your technology. All right, guys? So what I want you guys to do is I want you guys to now practice that with this last one here. I want you to go ahead and find your x-intercepts. Find that one. Here are the correct intercepts that you can find. Guys, remember, you're going to have to do it twice because there's 2 different zeros. So guys, if you are asked to find a minimum or a maximum or a vertex, you only got to do it once. If you are asked to find a 0, you're going to have to do it twice because there's 2 x-intercepts. All right? And then we are going to do one more lovely thing before I give you guys a chance to get started on your quiz. And guys, we are going to remember how to do the regression. We're doing all sorts of fun calculator things today. Okay? So, we are going to take a look at this quadratic regression right here. Alright guys, so no, this regression is on the calculator. I want to give you guys plenty of time, or this regression is on the quiz. I want to give you guys plenty of time on your quiz, so I'm going to do these little quick notes. So guys, we use regression. This is page 11 of your notes. Guys, we use regression when we are given a set of data and we are asked to write an equation from it. Alright? And so often, this is the kind of data that comes from real world. Okay? So specifically, ladies, if they are asking you guys to write a regression, that means you're going to get weird decimal answers. But guys, you can technically use regression anytime you see a table. Alright guys? You just have to know what kind of regression we're dealing with. In this case, this is talking about a projectile is launched into the air from the ground. The table shows the height of the projectile, ht, at different times. Based on the table, write the quadratic equation that best fits the data. So guys, based on this table, we have at 5 seconds, we know that it's 1,353 meters. They probably had some sort of like timer or counter on the object, and it took different heights at different times. So y'all, what we want to do is we want to find the equation that best fits this data. Now y'all, if a projectile is launched into the air, what do you think the path of that projectile looks like? It's going to go up and then it's going to come down. So guys, that's why a parabola is such a great shape for these kinds of things, because it goes up and it comes down. It responds to gravity there. So y'all, what you're going to do is the first step is, guys, you hit stat. So I'm going to follow these directions here. Okay, so the first step is we want to go ahead and we want to hit stat. We want to enter the data into our list. This should feel familiar. We've done this a couple times before with different equations. Okay? We want to enter all of our x values, 5, 10, 15, 20, 25, 30, 35. You want to enter all of your x values into your list 1. You want to enter all of your y values into your list 2. Okay, we want to enter all those y values into list 2 here. And guys, when we do that, what we do next is it says, okay, then you hit stat again, but this time we want to calculate. So we want to calculate. And what we want to calculate is quadratic regression. So you hit number 5, or you can scroll down to number 5. And then, guys, you can either hit enter 5 times or scroll down to calculate. And when it does, it spits out all of these lovely A, B, and C values. Now, guys, these A, B, and C values give you the A value. This gives you your values for your standard form of your equation. So I'm going to go ahead and write this out. So it looks like my A value is negative 4. I'm going to go 90. What? Negative 4.90. I'm going to round it to 2 decimal places. Okay? My B value is 294.96. And my C value is 0.57. Okay? So your C value is that 0.57. So now that you know your A, your B, and your C value, we can plug it in to the y equals ax squared plus bx plus c. So I'm going to say y equals, and for my A, I'm going to plug in negative 4.90 x squared. And then for my B, I'm going to plug in 294.96. And that's with your x. And then for your c, it is plus 0.57. So my equation is y equals negative 4.90 x squared plus 294.96x plus 0.57. Okay? And so regression is a wonderful tool to be able to use the real world data and to get a quadratic equation out of this. And guys, does it make sense that my A value is negative? Absolutely, because my parabola was going to be opening down in a little frowny face. All right? So what I want y'all to do is I want you guys to practice this regression technique on number 2. You can follow the steps, okay? And I want you guys to see how you do here on number 2. Practice that regression technique, and we're going to see how we do. I'm going to put up the answers in just a moment, and then we are going to get ready to take our quiz. All right, y'all, so these are the values that you should get for A, B, and C for this second one here, using that lovely regression technique.